All right, here we go with motors and other loads. So here this is very similar to the multi-motors, the concept of the feeder and things like that, only instead of coming out of the splitter where we would have multiple motors, we would have a few motors and a panel or whatever's picking up the other loads. So here we start with our motors here. So we got 30 horsepower, 600 volt, three-phase, service factor 1.3. So here the service factors aren't a factor. They're just presented here. One thing you want to be aware of is 600 volt, the voltage, and the phase. So some of these will be single phase. In this case, I'm using three phase as an example, but all the rules apply. If it's single phase, we use table 45. If it's three phase, we use table 44, and so on. So be aware of the horsepower rating of the motor, the 600 volt rating, and the phase. Service factor does not apply, but here motor 2 has a motor compressor, so we'll look at that. Right away. Here's some details. I'll go through this at the end of the calculation, but we have overcurrent protection as breaker, wire, T90 nylon copper, raceway EMT, motor squirrel cage, equipment 90% rated, 90 degree rated, starting not simultaneously, and we have some other loads here: lighting 20 kilowatts, power 15 kilowatts, and three-phase power 30 kilowatts. So these are both single phase here. So the first thing we're going to do is calculate for the maximum overcurrent protection for each motor, all under 28200 subrule 3A, and here 28708, because we have the motor compressor, the refrigerant motor compressor, deals with a code in there. So the first thing we want to do is line up our FLCs and get everything started. So what we're looking at here is for M1, 2, 3, 4, and 5, we have 32, 22, 11, 6.1, and 17 amps for them all respectively. And what we're going to do now is just bring them into this part of the calculation right here. So we want to have each one of these is going to require an overcurrent protection. So that's what we're doing here. We're providing some overcurrent protection for, so we take the 32 amps. Now, because we're dealing with a breaker, there's table 29 that we're dealing with here. I'll just drop that in there, and that's 28200 3A is dealing with table 29. That's where we're getting our 2.5 from, because we have the breaker as an overcurrent. So as we've always done, 32 times 2.5, this will be 80. We're going to do the same thing for M1, M3, 4, and 5. But here, M2, because of this refrigerant motor compressor right here, the 0.5 for the 50% is reflected through, or is regulated through 28708 subrule 1. So we have to make a little adjustment here. And this times 6. So that all is relative to your motor compressor here. So we multiply it by 6, then at 50%, and that's what we end up with here. And again, all through 28708 subrule 1. So then we can continue on. So just to say here what we're looking at: 80 amp overcurrent protection for M1, 66 amp for M2, M3 27.5, M4 15.2 or 15. These are all just ampacities, not the actual overcurrent devices. And 42 for M5. So that's how they will all be protected. So we go the motor load total amps here. So 28204 subrule 1 and 3 is just telling us how to assemble our amperage. It's telling us, as we've done in the multi-motor calculations, the same rules apply. We're taking the largest at 2.5, and then we're adding the FLCs of all the other motors. Again, all regulated through 28204 subrule 1 and subrule 3. So we add them all up. We end up with 136.1 amps, and I've circled this as 1. That means this is the first value that's contributing to the final, to the total. So here now, when we look at finishing all of this off, we're going to look at the other loads. So if we go back at this point, we have all of the motors pretty much wrapped up here. We know what we're doing. Overcurrent device, we know. We haven't calculated here for the individual wire sizes. We're just calculating for the feeder. So we know that each motor has its overcurrent device that it requires. So this value is contributing to the overcurrent device that's going to be protecting the feeder. So now when we look at the other loads, we look at 8100, 81046A, meaning continuous in this case, and 8100 as applied when we apply any kind of voltage. So here we look at our other loads. So we have a continuous 347 single phase. So we have lighting and power, just plain old PEI as we've always done. 20,000 divided by 347 gives you 57.6 amps. Power, 15,000 watts divided by 347. And again, this is not three phase, this is single phase. 43.2 amps, add them up, 100.8. And we have here, because this is continuous, these are the continuous loads, well, we have 81046A. We have to take that at 80%. So we're going to bump that up to 126 amps. That's 2. That's going to contribute to the final. And then we deal with our non-continuous loads, 347 volts, single phase. And we have that's 600 volts, three phase. So we have our power right here, 30 kilowatts. So 30 divided by 600 times the square root of 3, because it's three phase. We have 28.8 amps. That's number 3, contributing to the final. So now the feeder, we're looking at the maximum overcurrent protection and the minimum size wire for the feeder. So we have the total amps. We're going to add up 1, 2, and 3. So 136, 126, and 28.8 gives us 291 amps. So here the equipment is marked 90 degree rated, and again we're just playing with numbers here. The code book always assumes equipment is not marked. That will always give you the highest possible conductor size. But again, we're just playing with numbers here. So 90% rated, as we've always done, 4-00441B, table 2 gives us a 250 MCM, so a 291 amp load, 250 MCM conductor in the 90 degree column, and 1410418, table 13, as we always have, 250 amp MCCB. So notice right here, the maximum overcurrent protection, we calculated for 291. So here we just go the next size down for 250 amps MCCB. And then we can always size the conductor accordingly. Whoever wants to make any adjustments, you could always go up one wire size, up one breaker size, whatever that'll be. But that's about it. So just looking at the calculation here and taking a couple notes, we're looking at the three-phase values. So we got to remember to use table 44, not 45. This is where, so anywhere I've made used any colors or highlighted anything, this is where I get errors from students, okay? So here, three-phase, typically sometimes I'll get a table 45 value or something like that. Something will be missed here. So table 44, be aware what you're looking at here. If you see any single phase, you use table 45. When we look at what is provided here, it's telling you something. So notice right here, the overcurrent protection breaker, I have it in green and in red. Red meaning for the end of the calculation, that's going to be a breaker. But green here indicating how we're applying table 29. That's where the 2.5 is coming from, the breaker. They have different values for time delay and non-time delay fuses and breakers, so just be aware there. That's where I get some oversight. Here, when we deal with the other loads, we look at the continuous rating and the application of the 0.8, the 80% here. So that's where I get students will miss, they'll do the calculation and miss this 80% here to bump that up to whatever. Here, when we look at 4-004 and we want to size our conductor here, so we have T90 nylon copper. So it's 90 degree rated, T90 nylon. This is all indicating the 90 degree column, but copper, that's our table 2, right? Raceway is also conductors in raceway, as opposed to free air, where we deal with table 1 or table 3. So in EMT means that the conductors will be gathered together, or will be in proximity to each other. So again, that's another thing for table 2, and the equipment 90 degree rated. So that's the other indication of what wire to use. So we have equipment 90 degree rated. That's giving us our 90 degree column. Raceway is EMT. That's telling us to use table 2 because the conductors are grouped together. And the wire is T90 nylon copper. So copper is again our table 2 value. So just be aware there. For the starting not simultaneous, this is a reference to 28204 subrule 2. I don't need this code. I'm just making mention of what's going on in here. And that's about it. So just be aware in these highlighted areas. And yeah, right here, motor total loads, be aware that we're using our FLCs, no calculated values. For example, in here, I may have a non-continuous motor, in which case in this area we would apply table 27. But that's about it. So that concludes our lesson on motors and other loads.